It started to record. Hello everyone, this is the video class of Design Innovative ICT Infrastructures and Service. We will talk about OpenCube Toolkit and also the assignment guidelines. My name is Ricardo Mateus and I am here with my colleague Zagun Data and supervised by Marijn Jansen. The outline of the video today is we start with our assignment description. We go for linked open data lifecycle model, OpenCube toolkit tutorial, creating LOD, expanding LOD, and exploiting LOD. The assignment description. The assignment objective is to teach you how to implement linked open data, identify challenges and benefits of linked open data implementation and usage, develop user scenarios and use cases like application or web services, develop an ArchMate model architecture based on concrete situation. So you need to select a real situation for this architecture. Identify challenges and benefits using OpenCube Toolkit, and also identify value from data usage, like data analysis or services applications that you were supposed to create on this assignment. The flowchart of expected deliverables, we start giving you an open government data portal list. Yeah, you can enter there, you can check with the data sets that you have, you can collect that and treat and use. These users probably will be used on the OpenCube platform. We have a web-based platform, but you can also do a local installation. The three deliverables, we start with open linked datasets that we want you publish on the internet, taking in consideration that the datasets you are collecting are not yet open or linked. The second deliverable is product or application based on a real case. For example, you want to create a mobile phone application or a web-based application that people can go there and search something or provide service. And the third one is the report of perceived benefits and challenges during the implementation and usage of the OpenCube platform and the toolkit. The scenarios that we expected you work are on transparency and accountability, can be two groups on that. Public service delivery, doesn't matter if it's on the private or public organizations. Decision making, regulatory and legislative. And finally, entrepreneurship and economic growth. We expected two groups on each area, then we can have different kind of projects and applications. The expected timeline, we start in the first week, forming groups, selecting the area that you are working, potential data sets. Then you start the plan, a draft of application. We will give you a spreadsheet. It's a kind of a brief business plan. On the second week, you are expected to send to us the final spreadsheet business plan, and plus 2 pages of supporting your business plan. So it's a text that we expect you support. Why are you creating this application, and how many people, the demography, the graphs, just showing us that this is a good idea and you are reaching a lot of people. The third week, a presentation of your idea. We will give feedback on the draft of application that you sent to us, and the other groups that are not presenting, they are obliged to also make questions and try to give tips to improve the quality of the ideas and business plan applications that the groups presenting are presenting. Then we have 3 or more weeks, we don't know yet, but we are open to receive questions and guide you on using the OpenCube and the toolkits. Me, Ricardo, or my colleague Agung, and also Data. And finally, I don't know exactly which week, but you are supposed to deliver the 3 deliverables. The project application, also the open and linked data sets. Probably you will try to upload it on a public area. For example, you have the Open Data European website, and also a brief report of perceived benefits and challenges of application development and implementation and open linked data, opening up in linked data. We have a clear evaluation method. It's based on 6 dimensions. We have the factors and also the evaluation method, and of course the individual grade based on the factor, and the sum grade based on the dimension. Probably we will invite some colleagues to watch your presentation, and they will judge you based on this. So very transparent and clear how you do your evaluation. And check that for implementation, we have level of implementation, and you can earn 1 extra point for this if you deliver us commercial use. Yeah. Linked open data lifecycle model. We decided to create this simple lifecycle model to explain you that we can create data sets. Yeah. First, we need to collect, we need to storage, then we select which of the data sets that we will open and link. Then we go for data publication. Probably you will see that we need to harmonize, we need to cleanse the data, we need to create metadata, opening up data sets. Then we go for a third stage that we call data usage. We need to link data here, discovery, create process to discovery data, explore data, and exploit data. The data curation probably will be on all the stages, but we put here as a 4th element after we create, publish it, and use the data sets. Here we have some deep description of the stages and steps. Yeah.
Thank you, Ricardo. Hi, everybody. I'm going to explain for a couple of the next minutes OpenCube Toolkit reference architecture. OpenCube Toolkit is an example of a reference architecture created by OpenCube Consortium for statistical link open data. It is a reference architecture that contains open source components available for free use. You can freely download from http opencube-toolkit.eu. Beforehand, you need to make sure that you have already installed Java 7 or 8 in your system. As Ricardo mentions in the link open data lifecycle, there are 3 groups of tools according to the LOD lifecycles. The first one is creating LOD tools. The OpenCube Toolkit involves several tools, for example, Tarquel, D2RQ, Grafter, R2RML, JSONstat to QB. I will explain to you after this. The second part is expanding the existing data cube, including OpenCube Compatibility Explorer, OpenCube Aggregator, and OpenCube Expander. And the last part is exploiting the data cube, which is the hardest part, which involve tools for searching, querying, visualizing, and analyzing the data cube. For example, R statistical analysis, you might probably know, and interactive chart visualization. Let's move let's move on to creating LOD tools. The objective of the tools in this group is to convert data to RDF format that is standard of linked data. Tarquel is meant to convert CSV, Excel files, D2RQ, and R2RML are used to convert traditional database data such as MySQL, Oracle, Postgre, and so on. Is for converting JSON stat is for converting JSON structured data. Grafter is not part of the toolkit, but it's free to use and available in the internet. Let's move on to Tarquel. You can use this tool to convert flat files to RDF. The application and its syntax is available on http tarquel github.io. The application only runs in Linux, and before installing the application, make sure you have already installed Maven and Java 7 or 8 in your system. For example, we would like to convert this purchase data to RDF. There are date, hour, city store, product, total payment, and payment type. First, we tried the regular SQL script whether it works, in which we select city store and the amount customer pays. The second one is we create the Sparkwell script to convert the data into RDF. As you can see, the left part of the screen is the script and the right part is the output or the RDF data. The second tool we will discuss is D2RQ. It's used to convert traditional database RDBMS, for example, MySQL, Oracle, Postgre, Microsoft SQL, Informix, etc., to RDF. You can download and find the syntax from http://d2rq.org. Make sure that you have previously installed prerequisite applications as stated in the website. For example, the purchase data from previous example is stored in MySQL database. We need at least two steps to convert the data to RDF. First, generating a default mapping file. Second, dumping the database. Last, you can optionally run the D2R server. We will explain that later in the next slide. First step is to generate a default mapping file. The command generate mapping will map the table structure in the database to D2RQ file. The second step is to dump the database. Using the map file from the previous step, you then create the RDF. This tool also provides the D2R server, which has GUI for process and data management. Another tool is Grafter. It is a tool to convert XLS CSV files to RDF. You can find the software and the complete syntax from http://grafter.org. But you need to install Java 7 or 8 and Leiningen Clojure build tool beforehand. There are 4 steps to convert the data to RDF. First, creating project from the provided template from the Grafter. The second one, running pipelines so that you can feed the streaming data into the system. Third, transforming into tables that help you to query and read the data in a comfortable way. And last, transforming into graphs that is converting the data into RDF. There are other tools for creating LOD provided in the OpenCube toolkit. For example, R2ML, which you can find the software and syntax from GitHub and cons/r2rml dash parser and JSON statqb from GitHub RX data series slash JSON.qd. The last part is the second part, sorry, is the expanding LOD. These tools are needed if you have existing data cube and need to expand the cube. Expanding means adding new rows or columns to the cube as well as updating the existing data. There are three tools provided in the toolkit. There are OpenCube Compatibility Explorer, OpenCube Aggregator, and OpenCube Expander. However, you can skip this part if you have no previous data cube in the system. The last group of the tools and the most difficult part is the exploiting LOD. The tools included in the toolkit are for searching, querying, analyzing, and visualizing. In this tutorial, we will use R statistical analysis as an example. This is the example of R script to predict something. You can learn more about R script from many sources in the internet. For example, http www.r-tutor.com. The output of the previous R script is then visualized, for example, in this graph. I think that's all for the tutorial. If you have any further questions, please contact Marijn, me, Ricardo, or Data. I hope you can find the toolkit beneficial for your assignment. Success for you!